Okay, let's unpack this. We've all been amazed, I think, by how far AI has come,
Mm,
especially, with large language models.
definitely.
But have you ever felt like something crucial is still missing? Like um, a true understanding of meaning or the ability to really adapt when things change?
That's a really great point. What's fascinating here is that even with their advanced capabilities, traditional AI often struggles with what has been called a lack of meaning or intentionality
Right.
and adapting to dynamic contexts. Sloman, actually, way back in 1978, argued that current AI approaches often fail in giving meaning and intentionality to AI systems, and they just lack flexibility.
That's exactly what we're diving into today. Our sources, including Sophimatics, Logic, Ontology, and Mathematics and AI by Gerardo Iovane and Giovanni Iovane, and insights from researchers like Sloman, Hansen, and Hendricks, Lon et al. Well, they introduce us to Sophimatics, our mission, to kind of uncover how this framework aims to go beyond traditional statistical AI
Yeah.
by uh, integrating logic, ontology, and mathematics, trying to bring AI systems closer to contextual reasoning, handling ambiguity, maybe even ethical reflection.
And this isn't just about, tweaking existing models.
Well,
It's about grounding AI systems within a contextual framework while at the same time giving them meaning and intentionality. It really addresses the core of interpretability in ethical AI applications, things current systems often lack.
so what does this all mean for the AI we interact with today? Our sources point out that while, yeah, traditional statistical methods are powerful, they can lack interpretation and intentionality. What's the key difference in Sophimatics' approach?
Well, if we connect this to the bigger picture, traditional AI applications often draw on preset parameters, right, which limits their flexibility.
Okay.
Sophimatics constructs semantic interpretations by grounding intent, meaning, and contextual adaptation through both logical and ontological approaches, rather than just relying on statistical patterns. Okay. Here's where it gets really interesting, I think. Sophimatics achieves this by weaving together these three core pillars: logic, ontology, and mathematics.
Yeah, let's start with how Sophimatics redefines logic. It's modified not just to deal with abstract truths, but specifically with meaning and context.
Meaning and context.
Exactly. While preserving the invariance of logical truths, Hansen and Hendricks highlighted that many systems use logic just as syntax, sort of forgetting the need to consider its contextual impact.
So it's not just about if A then B, but more like if A then B in this specific context. And what does that truly mean for the situation? Is that the idea?
Precisely. Sophimatics uses rigid logical constants, those fundamental rules, but allows the variables to refer to dynamic contexts,
Ah.
which is crucial for interpretability. It's a philosophical approach, really, accounting for intentions, references, and varying ontological contexts. As Hansen and Hendricks argue, the relevance and applicability of the model have to be constantly analyzed. Okay, so logic handles reasoning within context. What about defining the context itself? That brings us to pillar two. Ontology, the study of what exists and how things are categorized. Our sources call integrating formal ontologies a significant divergence in AI. Why is this concept so crucial here?
Well, this raises an important question about adaptability. Sloman argued, again back in 78, that without adaptability, an AI model can quickly become useless as new data, ethical situations, perspectives, they change what truth means.
Right, the world changes.
Exactly. Sophimatics employs formalized ontologies that can dynamically change or add information and assumptions within the AI system itself.
So wait, instead of a fixed, predefined understanding of concepts, the AI can actually restructure its own categorization, its understanding of what a thing is as context shift and new information comes in.
That's right. It allows for self-categorization or self-ontologization, which is a major leap from traditional ontologies that Sloman claimed were just not designed to change. This flexibility lets AI interpret contexts previously inaccessible because of rigid boundaries.
So it stays relevant.
It means the AI's reasoning can remain relevant, even acknowledging, as Sloman noted, that an ontology will likely never be completely complete or accurate.
Okay.
And this dynamic approach also means AI applications within Sophimatics need a reflexive, critical approach to their own ontological representations. Constant testing and analysis. This gives AI systems more intentional and self-regulated processes. It's a feature of what Sloman called a generative AI paradigm.
Okay, logic, Ontology. And how does mathematics tie into this picture? It feels like it must be doing more than just basic calculations.
Oh, absolutely. Mathematics and Sophimatics is deeply involved in overcoming problems with time and context, things like incomplete data or really rapidly changing environments.
Okay.
Lana noted that traditional models struggle because they treat time as simple timestamps.
Yeah, just a point in time.
Right. Sophimatics introduces concepts like complex time. Think of it as t equals a plus ib with real and imaginary components.
Whoa, okay. Complex time.
Yeah, it sounds advanced, but it allows AI systems to deal with temporal representation, inference, even anticipation by extending a timestamp to interpret what it means temporally.
So not just when, but the meaning of the when.
Exactly. And then there are higher dimensional semantic spaces.
Okay, what's that about?
This is fascinating. A multidimensional semantic space lets AI encode ambiguous or unclear situations directly.
How so?
Instead of forcing an assumption or intent into a single vector-based framework, like Lon et al. Described, higher dimensions allow for overlapping and ambiguous interpretations to be embedded.
Ah, like holding multiple possibilities at once.
Precisely, which is crucial for AI operating in sensitive environments, like those involving ethical dilemmas, where things aren't black and white.
Makes sense.
Mathematics also enables the system to not only change interpretations, but also change its own ontological and semantic categories. Sloman suggested this could happen through mathematical self-reorganization, maybe attractors and topological manifolds, or mathematical bifurcation.
So math helps it reorganize its own thinking.
Yes, and it helps create sophisticated knowledge networks that encode not just associations, but higher-level relationships like causes or helps, which then mathematically adjust to stay relevant as contexts change.
This sounds incredibly complex, really demanding. What kind of expertise is needed to actually build systems like this? It's clearly not just coding.
It is truly interdisciplinary. Our sources, including Hansen and Hendricks and Lon et al., they stress that rigorous formal philosophy training coupled with formal computation training is absolutely necessary.
Philosophy and computation together.
Yes, for designing ethical and beneficial AI systems this way. Logic, ontology, and mathematics aren't just simple techniques you plug in. They're treated as a context-bound and evaluative endeavor.
So it's about constantly questioning, critically applying these tools with a deep understanding of their foundations, not just using them blindly.
Exactly. Hansen and Hendricks suggest there's been maybe overconfidence in what past mathematical applications can do on their own. Sophimatics emphasizes constant criticism of these techniques to ensure coherence with the overall context and, critically, with their purpose, especially ethical considerations. This applied critical manner is central.
That constant critique.
Yeah. And ultimately, the profound goal here is ethical AI. Sloman argued, really insightfully I think, that the key isn't to build a computational robot that is ethical, but one that can discuss or consider ethical topics.
Consider them not just embody rules.
Right, like rights and intentionality. Sophimatics enables this through its dynamic and flexible ontologies, allowing meaning-based interactions and critical reasoning to actually come to light.
Okay, let's try and wrap this up. Sophimatics presents, well, a really compelling vision for AI that goes far beyond just processing data or recognizing patterns. It feels like a leap.
What's fascinating here, what's really revolutionary, is its commitment to imbuing AI with meaning, intentionality, and that dynamic understanding of context. It's a paradigm shift towards truly adaptable and ethically reflective AI systems that constantly evolve their own understanding, built on this deep integration of philosophical rigor and computational design.
So what does this all mean for you listening? Imagine AI systems that don't just follow static rules, but truly adapt their understanding of the world, even their fundamental categories, as new ethical dilemmas or nuanced situations arise. It's a leap towards AI that can engage with the world in a far more human-like, reflective, and maybe even meaningful way.
Which, this raises an important question. If AI systems can learn to self-categorize, dynamically adjust their ontologies, and critically reflect on their own understanding, how might this change our own relationship with knowledge, with truth, even with ethics, in this increasingly complex and interconnected world we live in?